So for today's presentation, we're looking to talk to you about how to create an optimized industrial camera. A camera that resides in a tough environment, thermally challenged environment that is low in power and optimized in terms of cost. And so we would like to share our experiences with you here. Starting first, there are many choices in terms of processors that can be used for processing in a camera in general. And AI processing is a big portion of what we see happening in a lot of smart cameras that are coming up currently. So why FPGA as an architecture for processing video in a camera or for edge AI processing in general? So Lattice is a semiconductor company, and we focus on FPGAs specifically. We build small size FPGAs, FPGAs that are low in power. You don't see a lot of heat sinks with our demos. You don't see big, large supplies that are sitting around devices. So we focus on the 1 milliwatt to 1 watt in the power range. We service the small and the mid-size FPGA market. FPGAs by nature are a parallel compute engine, so very similar to GPUs, you can accomplish multiple goals in parallel. Very different from how CPUs will execute sequential transactions one at a time at a clock speed. And you can crank up this clock speed in order to achieve better performance. FPGAs are a bit different. You have a parallel machine that it can execute multiple things at the same time. So parallel compute, our clock normally is 150, 200, 250 megahertz. You end up accomplishing the same goal at a much lower power budget. Next, the computational resources that are available within an FPGA, such as the fabric itself, DSP blocks, memory blocks, can be used for a variety of purposes and use cases. So it can be for pre-processing, conditioning signals as they come in. An ISP is a great example of that. Filtering data to make sure that the right data is getting into the processing itself. In addition to that, we're able to scale use cases, so you can have a single use case running for a certain amount of time, then reprogram the FPGA fairly quickly and have another use case running right after that. So context switching within use cases happen very quickly with FPGAs, and especially the FPGAs that Lattice produces. Security, FPGAs do not normally have firmware that's running. They're built in hardware, so you can create secure security schemes that will protect the bit stream that's running on the FPGA or the design itself during runtime or during boot up. The final point here for why to use FPGAs for edge AI is hardware programmability, and I'll go to the next slide for that.